All stories have an ending, even the story of the universe itself. From the first brilliant flash of creation to a silence deeper than any night, everything that begins must one day conclude. Time refuses to halt or reverse. It marches onward, indifferent to the beauty and chaos it leaves behind. The universe, too, is subject to this relentless forward motion. Today, we travel not just beyond the stars, but beyond the ages. Billions, trillions, even quadrillions of years into the future, to witness the final chapters of existence and contemplate how, one day, everything may come to an end. To understand the fate of the cosmos, we must first grasp the subtle force that shapes all things. Entropy. Entropy is the universe's inherent tendency toward disorder, a law as fundamental as gravity or light. Imagine a child's room, meticulously organized, every toy in its place. Left unattended, the room descends into chaos. The universe, since its inception, has followed a similar path. At the moment of the Big Bang, all energy and matter existed in a state of almost perfect order, a low entropy arrangement. But as the universe expanded and cooled, order gave way to chaos. Stars formed and died, galaxies collided, planets emerged, and life, even consciousness, arose, all while entropy quietly increased. Entropy is the arrow of time itself. It is why we remember yesterday but not tomorrow. It governs the direction of change, ensuring that things fall apart far more easily than they come together. The more ordered a system, the more it yearns to break down. This is why hot coffee cools, why buildings crumble, why living things grow old. It is the cold mathematics of probability played out on a cosmic scale, and it is utterly unstoppable. Even our sun, burning with a seemingly eternal light, is only a temporary triumph over entropy, a fleeting structure in the ceaseless drift toward disorder. All the beauty of the night sky, the swirling arms of galaxies, the blazing fury of stars, the quiet glow of planets, is part of a grand, ongoing transformation. Stars themselves are born from clouds of gas and dust, igniting in nuclear fire. For billions of years they shine, fusing hydrogen into heavier elements, resisting the pull of gravity with outward pressure. But this delicate balance cannot last forever. When their fuel runs out, stars die. The fate of each star depends on its mass. Modest stars, like our sun, expand into red giants before shedding their outer layers and collapsing into white dwarfs, dense, cooling embers that will linger for eons. Massive stars die more spectacularly, exploding as supernovae, seeding the cosmos with heavy elements, then leaving behind neutron stars or, for the heaviest, black holes. Galaxies, too, are not eternal. Over astonishing stretches of time, their vast gas reservoirs are gradually consumed by star formation. As each new generation of stars is born, the supply dwindles. Eventually, no new stars can form. The existing stars, one by one, exhaust their lifespans. The galaxies grow dim, populated only by the remnants of stellar corpses and the ghosts of what once was. This is the stellar fade, the slow extinction of the cosmic lights. Yet the universe's ultimate fate is not set in stone. Cosmologists have suggested 3 major ways the story might end, each dictated by the fundamental forces and ingredients of reality. The first is the heat death, sometimes called the Big Freeze. In this scenario, the universe continues expanding forever. Galaxies drift apart, separating by ever vaster distances. Over time, the energy of the universe becomes evenly spread out, approaching a uniform, featureless state. Stars burn out, black holes evaporate, and all motion ceases. No more structure, no more change, just a vast, cold nothingness. This is maximum entropy, the endpoint of disorder. The second theory is the Big Rip. Here, a mysterious force called dark energy, which currently drives the accelerated expansion of the universe, grows stronger with time. If it increases without bound, it will eventually overcome all other forces. Galaxies tear apart, stars are ripped from their orbits, planets shredded, and even atoms themselves pulled asunder. The universe ends not in cold silence, but in a violent final stretch, a cosmic rending that spares nothing. The third possibility is the Big Crunch, or perhaps a Big Bounce. If the universe contains enough mass, gravity could eventually halt its expansion and reverse it. All matter and energy would come rushing back together, collapsing into a final singularity. a moment of infinite density and temperature. Some speculate that from this singularity, a new Big Bang might erupt, birthing a fresh universe in a never-ending cycle of creation and destruction. In all these futures, one player stands apart: the black hole. Black holes are the graveyards of stars, regions where gravity reigns supreme. Over unimaginable timescales, as stars and planets vanish, black holes will be the last titans standing. Silent, invisible, patient. But even black holes are not truly eternal. Thanks to a subtle quantum effect known as Hawking radiation, they slowly leak energy, shrinking ever so slightly with each passing eon. For the largest black holes, this process takes a mind-boggling span of 10–100 years or more, a number so vast it defies comprehension. When a black hole finally evaporates, it does so in a brief explosion of radiation, the last flicker of cosmic activity before utter darkness claims all. After the stars have died and the black holes have faded, the universe enters what physicists call the degenerate era. Only the faintest relics remain: white dwarfs, neutron stars, and the occasional rogue planet, drifting in perpetual night. These remnants, too, are not forever. Over quadrillions of years, white dwarfs cool to become black dwarfs. Cold, invisible cinders. The rare collisions of these objects might trigger a brief flare of light, but such events grow rarer and rarer. Eventually, even these embers fade. Planets, long separated from their parent stars, wander alone through the void, their surfaces frozen solid, their atmospheres long since lost. Galaxies, if they can still be called that, are just sparse clouds of degenerate matter and dark remnants, drifting further apart with every passing epoch. But is there a limit to how long even matter can endure? The answer may be no. On timescales so vast they make the lifespan of stars seem like the blink of an eye. Protons themselves, the building blocks of atoms, may decay. If this is true, then the very fabric of matter will eventually unravel, leaving behind only a thin mist of subatomic particles, or perhaps radiation alone. Quantum processes, such as tunneling, may cause the last structures to collapse or transform, until even the memory of form is erased. And then finally silence. The universe began in a burst of unimaginable energy, a singular moment of creation that gave rise to all space, time, matter, and possibility. Through chaos and order, fire and ice, birth and death, it has played out an epic drama across the ages. But if the laws of physics hold true, it may end not with a bang, but with a whimper. No grand explosion, no final battle, just the steady, inevitable drift into darkness. No more stars to shine, no more worlds to turn, no more minds to wonder. A universe at rest, having spent its last reserves of order, content at last in oblivion. And yet there is a strange beauty in this story. From creation to collapse, from the first spark to the last ember, the cosmos is a single, continuous narrative. Every star that ever burned, every planet that ever circled, every life that ever looked up in wonder, all of it is part of this grand tapestry. We exist, for a fleeting moment, in the golden age of the universe. Ours is a cosmos ablaze with light and life, where the fundamental forces are in delicate balance and the possibilities seem endless. But this era is temporary. Against the backdrop of eternity, the time of shining stars, swirling galaxies, and living worlds, is but an instant. The universe will grow old, it will grow cold, and it will, one day, fade away. Yet perhaps this is not the end of all things. Some theories suggest that the death of one universe may give rise to another. In the Big Bounce model, each collapse is followed by a rebirth, a new Big Bang, a new cosmic story. Other ideas propose the existence of the multiverse, an infinite sea of universes, each with its own beginning and end, its own laws and histories. In such a view, our universe is just one chapter in an endless library of stories, each as wondrous, tragic, and sublime as our own. As we contemplate these ultimate destinies, we are reminded of our place in the cosmos. We are not merely passive observers. We are the universe made conscious, able to reflect on its own existence and fate. The atoms in our bodies were forged in ancient stars. The light in our eyes once traveled across galaxies. For a brief moment, the universe knows itself through us. We are lucky to live in this golden era, when the night sky is alive with stars, when the galaxies still dance, when life and thought are possible. We are witnesses to the story of everything, and our own stories are woven into the greater cosmic tale. And so, while the end of time may be cold and silent, the journey itself is filled with wonder. Every question we ask, every discovery we make, every act of creation or kindness adds a brushstroke to the vast mural of existence. The universe may end in darkness, but its story is one of light. Tomorrow, we will travel even further, beyond the end of our universe, to the parallel realms of the multiverse. For now, we look up at the stars, grateful for the fleeting spark of consciousness, marveling at the beauty of a universe that, for a time, was alive. And even as time's arrow flies onward, and the last fires die away, the memory of our brief, shining moment may echo forever in the silence that follows. In the end, perhaps that is enough.